Welcome to this lesson on equivalent ratios. We're going to talk about taking ratios and determining if they are equivalent and how to find equivalent ratios. So we're going to go ahead and start off with word problems because a lot of finding equivalent ratios, the math behind it is much the same as the math behind finding equivalent fractions. But you have to remember that fractions and ratios are different, right? So really what we're going to focus on is depicting and understanding what it means when you're creating equivalent ratios. So here we have Mason and Laney who ran laps to train for the long distance running team. The ratio of the number of laps Mason ran to the number of laps Laney ran was 2 to 3. Okay, so it is important to note that the ratio is 2 to 3 and that Laney would be the 3 because she's second. And then that Mason would be the 2 because he is listed first. So in the problem it tells us Mason to Laney, so 2 goes with Mason and 3 goes with Laney. All right, so the 2 to 3 is important. If Mason ran 4 miles, how far did Laney run? So what we're going to do is make a tape diagram. And what this is you're basically just making boxes to represent each of, in this case, each of the other person's laps. So here we have Mason, and I'm just going to use an M for Mason and L for Laney, and for every 2 laps he ran, Laney ran 3 laps, because remember that's what that means. For every 2 laps that Mason ran, Laney ran 3 laps. So now we want to know if Mason ran 4 miles. Okay, so if Mason ran 4 miles, what that means is we can assume that right now this is a mile and this is a mile. So it would be 1 mile, 1 mile, 1 mile, 1 mile, 1 mile to equal 2 to 3. Well, now we want Mason's laps to equal 4 miles. Well, you know very well that in order for Mason's laps to equal 4 miles, each of his boxes then has to be worth 2. Okay, so what this means is, right now this is a lap, so each lap was worth 2 miles. Okay, so one lap was worth 2 miles and the other lap was worth 2 miles, which gave you a total of 4 miles. However, if Laney, so everything has to be equivalent, everything has to be fair, we'll say. So that means that now each of Laney's laps has to also be equal to 2 miles, which tells us that she will have ran 6 miles. So Laney will have run 6 miles. Now again, what the tape diagram shows you is that for when we started, each of these was worth 1. But then, because we wanted Mason's boxes to equal 4, we didn't make 4 boxes. We said, okay, in order for this to equal 4, we know that each box has to be worth 2. And then if each box is worth 2, or in this case, each lap, because this is a lap, and this is a lap, then that means the same thing for Laney, that each of Laney's laps would have to be 2 miles. So it would make sense that if Mason ran 4 miles, that Laney ran 6. Because while he's doing those 2 laps, she's able to get 3 laps done. So she's able to get that extra lap in and get that extra 2 miles. Right, so now it's the same idea. So we have Laney who ran 930 meters, and we want to know how far did Mason run. This is a little bit harder though because this isn't a nice, easy number for us. So there's going to be some math that goes into it. So again, we have Mason and we have Laney. And for every 2 laps that Mason ran, Laney ran 3. Now again, are these perfect? No, absolutely not. I want you to try, don't draw it with a line here and 1 and 2. Just make sure that you're drawing them as close to equal as possible so that way your representation makes sense. Again, this is not how I expect you to solve these all the time. This is our part where we are understanding what's going on. So here I have Lainey who ran 3 laps, and those 3 laps have to be equal to 930 meters. So what that means is I can figure out each lap by taking the 930 meters and dividing it by 3, the number of laps that she ran. And I will get 9 divided by 3 is 3, 3 divided by 3 is 1, 0, and then of course we have the 0 at the end. Okay, so each lap is worth 310 meters. Now, if each of Lainey's laps is worth 310 meters, then that means that each of Mason's laps have to be worth 310 meters as well, which means he would have ran 620 meters. So then we write our sentence. Mason ran 620 meters. So looking at this, my new ratio here would be 4 to 6, because we have to do Mason to Lainey, and 620 to 930. Now, if you look at it, the size of our tape diagrams never changed. Okay, these two are still the same. This is still 3, this is still 2. Okay, nothing ever changed. What we did was we said, okay, originally this was worth 1 lap, now it's worth 2 miles. So what we're doing is we're saying, okay, well, 1 lap is equivalent to 2 miles. We're making equivalent ratios. Right? So now instead of this being 1 lap, it's 2 miles. There we go. Or instead of this being 1 lap, because it's still 1 lap, it would be 310 meters. So we can say that the ratios 4 to 6 and 620 to 930 are both equivalent to 2 to 3. Right. So this is the understanding behind it, and yes, you're going to be asked to draw a picture to show your understanding and to show how this is making sense to you, so please get used to the tape diagrams when we're talking about showing our thinking and drawing a picture to relate it to the problem. All right, so we're going to continue here with this example about the library books. And first, what we want to look at is this question of how can you determine who is right? So in this case, we're not even really looking for a mathematical answer necessarily. We're looking to see how can we determine who is right. However, we do need the math background to figure out what we would need to be looking for. So in this case, we want to look and see that the morning announcement said that 2 out of every 7 6th graders in the school have an overdue library book. Jasmine said that would mean 24 of us have overdue books. Grace argued that was way too many, or that was way too high. All right, so let's look at the important numbers here. It would be important to note that 2 out of every 7. Okay, now 6, even though it's written in number form, that is not important. That just tells us that we're talking about 6th graders, so that's not an important number. Okay, and it is important to know that 24. Now here's where having another color highlighter is pretty helpful, because 24 have overdue library books. And here it says that 2 out of every 7 have overdue library books. So we know in this case that the 2 has to go with the 24 because both of them represent people with overdue library books. So that's important because when we set up our ratio, we have overdue, and we'll say people with overdue, to total people. So in this case, there are 2 total people of every 7, and Jasmine is saying that that means that 24 have overdue library books, but what we don't know here is how many total students there are. So if Jasmine is saying that 24 students have overdue library books, we would have to know what that total is. So we would have to know the total number of students to know if she's correct or not. So we would need to know, and not the total number of students, the total number of 6th grade. To know if Jasmine is correct. Okay, because in order to figure out if these are equivalent, because we're figuring out if, we're not trying to find the missing piece, we're trying to figure out if, we would have to know, since we know that 2 times 12 gives us 24, we would have to know if whatever x is, if 7 times 12 gave us x. And we don't know that because we don't know x. Okay. If we knew x, though, so in this case, we could solve for x, but if we don't know what x is, we can't say for sure whether or not Jasmine is right. Okay. And actually, let's go back and take a look at that and say, all right, well, what would x need to be in order for Jasmine to be correct? Well, if there's 2 to every 7, and if you feel like you can get this without going through it with me, please go right ahead and do that and come back and check your answer. So 3, 4, 5. So 1, 2, 3, 4, 5, 6. And I need one more. So now, to get to this equaling 24, each of these has to be 12. So then each of these would have to be 12. Which altogether would give me 84. So in order for Jasmine to be correct, there would need to be 84 total 6th graders. Right, so we can even find that missing value by using the tape diagram and by using some math. So here we said that mathematically we know that 2 times 12 gave us 24, and I know that in order to stay equivalent, whatever I do to the number of students with overdue books, I have to do to the students in total. And I know that 7 times 12 would give me 84. All right, so we're going to decide whether or not each of the pairs of ratios are equivalent. So what we can do is we can actually set them up like a fraction, 6 to 11, and see if it's equivalent to 42 to 88. Okay, in this case, I know 6 times 7 gives me 42. So 6 times 7 gives me 42, so that way 11 times 7 would have to give me 88. Since that's not true, these are not equivalent. And again, you can even draw your pictures with your tape diagram and see that each of them would have to be worth 7 in order for that to work. And when you do that, you only get 77 on the bottom and not 88. Right? So here we have 0 to 5 and 0 to 20. So now to go from 0 to 0, I would multiply by 0. But in this case, I can't look at that because of the fact that I have 0 on the top. I have to look at the bottom first. So I know that 5 times 4 gives me 20. Well, does 0 times 4 give me 0? Since it does, I know that these two are equivalent. So again, that's just the math behind it when you're checking to see if they are equivalent. Then this last problem, I want you to go ahead and try on your own, and this is where you are actually going to try to find that missing number of walnuts to figure out how many walnuts would be in the party mix if the ratio is 5 to 6. So yes, I do want you to do your tape diagram to show a picture of what's going on. So again, it's always a tape diagram of the original, and then when you do that, you go back and you say, okay, well, in the original, I have 5 walnuts, and 6 cashews. Now in the new, I don't know my walnuts, but I do know my cashews. Right? And so there's your little bit of help for that. As always, if you have any questions, please be sure to write them down or email me so we can go over them in class.